Hey, folks, before we get started, I want to personally invite you to a live taping of this show in New York City on September 11th with the one and only Yuval Noah Harari, the best-selling author of Sapiens and Homo Deus. I'm really looking forward to this one. We'll be discussing his new book, Nexus, A Brief History of Information Networks from the Stone Age to AI. You won't want to miss it. To grab your ticket, which includes a free signed copy of Yuval's book, visit nextbigideaclub.com/events. There's also a live stream option for folks who can't make it in person. You'll find a link in the episode notes. All right, now on to the show.
LinkedIn presents.
I'm Rufus Griscom.
And I'm Caleb Bissinger.
And this is The Next Big Idea. Today,
how AI, biotech, and genetics will converge
and change the world as we know it.
So Rufus, I want to tell you a quick story. I was on a cross-country flight recently, and I was sitting next to this young woman. She was probably like 16. And as we flew, I engaged in what is my favorite pastime as an airline passenger. I watched her seatback screen over her shoulder.
Irresistible.
Oh my gosh, I know. The flight was a few hours long, and she spent the entire time, much to my surprise, watching this.
Is that Friends?
Yes, Friends, a TV show that ended probably before this girl was even born. I should interrupt here and say, Rufus, are you a Friends fan? Were you a Friends fan?
Friends fandom was not optional in the 1990s, Caleb. It was mandatory. It was kind of like having an extended family that we were all born into, like it or not.
But it's totally optional today, right? And that's what was so weird to me, that like, here is this person watching a show that's 30 years old, and I'm trying to figure out, like, what does she find relevant about this? And the conclusion that I came to, somewhere maybe over Tennessee, is that the world of Friends, the world of the show, it looks an awful lot like the world that my seatmate is living in right now.
Well, minus the internet, smartphones, electric cars.
No, I know, that's true. But like the clothes that the characters wear, the furniture that they sit on, the problems they have, the jobs they work.
It's vice president of a company that does data reconfiguration and statistical factoring for other companies.
Wow, how do you know how to do that?
That's what I do now.
It's all surprisingly contemporary. And I think your guest today, Jamie Metzl, would say that's because the world evolves really slowly.
But that, Jamie would hasten to add, is about to change.
That's right. He thinks the world 20 years from now won't look anything like the world of Friends. It won't look anything like the world today either.
So what we're seeing is acceleration of everything that touches technology, everything that can be digitized. And it doesn't take much. You just have to map out the big jumps in human technological evolution, going from the domestication of plants and animals to industrialization and electrification and the computer revolution and the AI revolution. I mean, the time between these different quantum leap revolutions is just getting shorter.
That's Jamie, and he's getting at the thesis of his new book, Superconvergence, which I'd sum up like this. All these radical technologies, AI, genetics, biotech, they aren't just speeding up, they're coalescing, converging in ways that are going to fundamentally transform healthcare, our food systems, the world as we know it. And we need to start getting ready now because this rapid change is going to require us to answer some pretty complicated personal, global, and regulatory questions.
And Jamie is kind of the perfect person to help us start wrestling with some of those questions now. First of all, he's a nerd. He's got a law degree from Harvard and a PhD from Oxford. Second of all, he's a seasoned policymaker. He worked in the Clinton administration. He's worked for the World Health Organization, the Council on Foreign Relations. And he's also, in the words of the Wall Street Journal, a science autodidact. So this guy kind of sees it in 360 degrees.
Indeed. I want to be careful with spoilers, Caleb, but this one left me pretty exhilarated about some of the tech-driven transformations we're likely to see in the next decade.
That's interesting. Say more about that.
Well, we talk about some pretty astonishing stuff in this conversation that, according to Jamie, is coming very soon. Personalized precision healthcare, lab-grown meats that could be more ethical, nutritious, and environmentally friendly than regular meat. Building with bioengineered spider silk, I love this, that's 3 times stronger than Kevlar and more flexible. Skyscrapers that could be grown like coral reefs.
Unbelievable.
And using DNA for data storage that's wildly more compact and efficient. This is crazy stuff, and it's not science fiction. It's all stuff that's in development now.
And as Jamie points out, if we do it right, the future of biotechnology is less synthetic than it is just kind of leveraging solutions that are already out there in nature that have evolved over the last 4 billion years. That's if we do it right. If we do it wrong,
we can't afford to do it wrong.
No, we can't.
Nor can we afford to keep things as they are, Jamie tells us. We have no choice but to lean into technology to build the future that we want. And the first step is imagining it. So let's do that with help from today's guest, Jamie Metzl.
The LinkedIn Podcast Network is sponsored by TIAA. TIAA makes you a retirement promise, a promise of a guaranteed retirement paycheck for life. Learn more at TIAA.org/promises pay off.
Jamie Metzl, welcome to The Next Big Idea.
Thanks so much, Rufus. Thrilled to be here with you.
Jamie, you've written a book called Superconvergence, How the Genetic, Biotech, and AI Revolutions Will Transform Our Lives, Work, and World. Though you're certainly sober-minded about the challenges we face, I get the sense that you think our future is going to be pretty good, or we have a good shot at having a pretty remarkable future. Is that fair?
Yeah, I think it's fair. I mean, I'm not a techno-optimist or a techno-idealist and some people think we should just do nothing and let the technology play out and it'll solve all of our problems. I don't think that at all. I think that we are developing these almost godlike capabilities that give us the potential to do these amazing things that will make our lives and our world much, much better. But if we don't manage them wisely, these same capabilities could do a ton of harm. And that's why I've written the book, to help people understand what's happening, what's at stake, what the bad story looks like and what the good story looks like, and what are the things that we can do now to increase the odds of the good story happening.
Could you paint for us a picture of what the good scenario might look like? Like what could our world look like in, let's say, 20 to 30 years?
The way I like to think about it is all of these capabilities, genetics, biotech, AI, over time will become general purpose technologies like agriculture or industrialization or energy that are really going to touch everything. So we need to think more broadly about where these revolutions are taking us. Certainly in healthcare, transitioning from our current world of generalized healthcare where you're treated based on your being a human to personalized or precision healthcare where you're treated based on being you. So in healthcare, that's going to move us to our next phase from generalized to precision, and then from precision to predictive and preventive, which is going to help us treat and maybe cure lots and lots of diseases in a way that people are going to be really excited about. It's going to help us live healthier, longer, more robust life. But the big change here is that human beings are ramping up our ability to engineer intelligence and re-engineer life. And those are much bigger stories than just us or just healthcare. So in agriculture, we're going to transition to, if we get this story right, to just being more productive in our agriculture with less inputs of land, water, and fertilizer, thinking differently about animal products that we use, going from slaughtering 72 billion land animals per year, 200 million metric tons of fish, to growing some of those animal products that we want through stem cells and the cell cultivation and fermentation. And then thinking differently about industrial materials, moving from models of cutting down and digging up to growing, data storage. Really across the board, we're going to be able to get the things that we want, live the lives that we want, but just do them in better ways. And over the longer term, we're going to have to leave this planet because this planet is time limited. And we're going to have to become a spacefaring species, which we can. It's going to take centuries or millennia. But these are some of the capabilities that are going to help us do that. So I could go on and on and on, and I do in the book. But that's why I'm positive. I know you're going to ask about the negatives. I could make an equally as great as that list is. I can come up with a terrible list about the things that could go wrong. And that's why I think we need to balance the good story and the bad story.
Looking at the pace at which this is likely to occur, you write, we'll progress more in the next 14 years than we have in the last 100 years. The following 7 years will be another 100 years of progress. So that's an extraordinary claim. It suggests exponential tech progress, not linear. Do you think there's clear evidence of this?
Oh, absolutely. I mean, so what we're seeing is acceleration of everything that touches technology, everything that can be digitized. And it doesn't take much. You just have to map out the big jumps in human technological evolution, going from the domestication of plants and animals to industrialization and electrification and the computer revolution and the AI revolution. I mean, the time between these different quantum leap revolutions is just getting shorter. And that's why the title of the book is Superconvergence, is that we're having, it's not just that there's any one technology, it's that all technologies are embedded in all other technologies. I mean, we can go to ChatGPT or be using really cool AI and just think that, oh, this is new technology. But it's really old technology, because every time we're using AI, it is the domestication of plants and animals and the agricultural revolution that are making that possible, because you needed to have the agricultural revolution to get civilizations. You needed to get civilizations to have writing. And then if just the computer code on the computers that both you and I are using, if you just print out those codes, what are they? It's Latin letters, which are really ancient Phoenician letters. It's Arabic numbers, which are really Hindu numbers. It's all these kind of ancient technologies of writing that are underpinning the computer revolution, which make the machine learning revolution possible, which make the AI revolution possible. And with the tools of AI, we're able to interrogate natural systems, like how a plant diffuses nutrients through a leaf, and then use those evolved models to build better computer chips that speed everything up. So everything is accelerating. And that's why the first chapter of the book is called The Nature of Change, because if we don't internalize this shift in the rate of change, we're going to be way too conservative in our personal lives and in our communal lives.
I think a lot of people's minds go to dark places when we think about what a radically different future might look like. When we hear that we should expect change to increase exponentially, not linearly, and that the world 20 years from now, let's say, could be much more different than I think the average person believes it will be. And I suspect this may be partly due to a kind of status quo bias that most of us have, that we're kind of afraid of change. We like our current world and assume changing it significantly is a bad idea, which we can understand, right? It's a kind of Hippocratic oath, like if it ain't broke, don't fix it. But as you say, I think this may be a problem, because you make the case that we need to imagine what's possible to create the path to the world we want.
Right.
Change is inevitable at this point. And at one point you say, failing to imagine how to co-evolve with our technologies is not a vote for nature or a vote for the past. It's a vote for nihilism.
Yeah. So
can you expand on that?
So a few things there. I mean, one, I get that people have this status quo bias, and yet, if you just look at the past 20 years, we've seen these radical changes. But the problem is, once a change happens, people just forget that it's new. It's like, oh yeah, that old thing. We incorporate change so rapidly. And we have this fallacy of thinking that our lives now are natural. And the stuff that we're not doing now but could do, that feels unnatural. I mean, when people are going nuts about genetically modified crops, people don't recognize or internalize that all of agriculture is radical biotechnology. I mean, it's insane biotechnology. And the difference between a genetically modified corn and non-genetically modified corn is nothing compared to the difference between corn and its wild predecessor. And so if we don't recognize that the entire, at least, for many millennia history of our species, but even for longer with fire and other things, the history of our species is our coevolution with technology. We're going to get this story wrong. We are who we are and where we are, and we live the lives that we do because of our coevolution with technology. So the question is not technology, yes or no. The question is technology, how best? And the reason I've written the book is I think everybody needs to play some type of role at every level in trying to answer that question, because how we collectively answer that question will have massive consequences for the future of our species.
You make a case that there's a special kind of potential facility that AI has with biotech, and the intersection of AI and biology is kind of a special one. I was kind of blown away by a quote you have in the book from Demis Hassabis. He's the founder of DeepMind, the lab that used AI to solve protein folding. He says, you quote him as saying, biology can be thought of in a fundamental way as an information processing system. On a physics level, that's what biology is. DNA is the most obvious example of that. He goes on to say, AI could be the perfect description language for biology in the same way that math perfectly describes physics. Like, wow. So as math is to physics, AI is to biology. And then he goes on to say that though biology is an information system, it's incredibly messy, complicated, emergent system. It's a soup of signals and patterns that's really hard for us to fully grok. But this is exactly what AI does well, right? That we've watched AI organically decipher and translate hundreds of languages. It would appear to be exactly the right technology to decipher and translate and modify the language of biology.
Yeah.
Is that what you see?
Certainly,
coming?
I see that happening, but there's a question of timing. I lecture in a lot of different places, and I always ask this question of different groups, including top scientists and others. And that is, if you assume that understanding the full complexity of all of human biology is 100, and understanding nothing is 0, where are we right now in our understanding of the full complexity of human biology? And people give different answers. But my answer is about 2 or 3. We understand about 2 to 3% of the full complexity of biology. But having said that, that's way more than we understood 100 years ago. And 100 years from now, we're going to understand a lot more. The complexity of our biology is not increasing. Our biology is about as complex as it was 1 million years ago. But the sophistication of our tools is increasing exponentially. So we're going to move up that scale. Right now, we can't understand fully what's happening even in a single cell, let alone in the context of trillions of cells interacting with each other in dynamic systems that are themselves interacting in real time with the shifting environments around them. So we may never get to 100, but right now, all of medicine and all of healthcare exist within just that 2 to 3%. And we have all of these hacks, and whether it's oncology or cardiology or neonatology or all of these incredible fields that we're all beneficiaries of. So we're going to move up that complexity scale. And as we do, we're going to have many more opportunities, not just to understand, but to understand, manage, and manipulate.
And we have a good number of problems to solve as it happens.
Unlimited. I mean,
so we could use all the tools we can get. Right. Chief among them, one of many, is our food system, agriculture, right? Half of all arable land on planet Earth is currently allocated to agriculture. The other half is wild spaces, forest, wetlands, tundra.
Right.
What happens if our current expansion of our agriculture system as it exists today continues? What would be the consequences if we did not, if we don't innovate, what happens?
So right now, we have 8 billion humans on planet Earth, as I mentioned. Projections are that we're going to go up to about 10 billion, and maybe we'll drop off after that. It's a whole lot of people. It's more people than we've ever had on this planet. And we are a rapacious species. And so in order to feed us, and we have this abundance of food, even though it's not well distributed, we have basically cleared all of this land, and we're clearing more and more land in critically important places like the Amazon rainforest and elsewhere in order to feed us. And it's crops and it's animals. And I'll talk about animals in just a second. And so if we go from 8 billion to 10 billion, and if we go from however many billions of people who are living lives kind of like us, and let's say it's 4 billion of those 8 billion, to 8 billion of the 10 billion having diets like us, we're going to need to double or even triple our agricultural land. And the only way we're going to be able to do that is by decimating, unless we change other things, decimating our wild spaces, driving millions of species into extinction, and putting ourselves at risk because we are living parts of a living planet. So we can't do that, and we're not going to do that. And so then the question becomes, how do we increase agricultural productivity? And so certainly with plant agriculture, we need to be developing varieties of plants that grow faster and produce more food with less inputs of land, water, and fertilizer. And the tools of biotechnology, that's how we got here, and it's how we're going to do that. But there's an even bigger challenge, and that is the footprint of animal agriculture. Industrial animal agriculture is just huge. 75% of all animal agriculture is industrial animal agriculture. And it's if you visit one of these places where there's gazillions of pigs or cows or chickens, it's actually a pretty horrible experience. I said before, we're slaughtering 72 million land animals per year. But not only that, 3/4 of all of our agricultural land and our emissions are supporting animal agriculture, whether it's food for animals or where just places where the animals are. And it's about a 30-to-1 conversion rate. So a cow will consume 30 calories of plants to produce 1 calorie of cow protein. And so the question is not, should everybody in the world become a vegetarian? I just think it's a fool's errand to say, all right, we have a strategy, and that strategy is everyone in the world is going to become a vegetarian tomorrow. So the question is, how can we get the animal products that we need without all of these negative externalities? And so it turns out that we're in the beginning of exploring a different ways, and that is rather than killing, let's say, a cow, you extract stem cells from the healthiest cow you can find or grow. And then you expand those cells in a culture in a laboratory and expand that in an industrial bioreactor. And I know people say, oh, yuck, food from an industrial bioreactor, but it's biologically identical. So I do think that we can start making changes and transitions in our food supply that really nobody's going to even notice, but it requires a lot of investments, and certainly our governments need to be investing in building this field. And we have to address the cultural issues of fear. There's like a cultural feel, oh, that doesn't seem natural. And that's, again, why I just want to help people open their minds about what is and isn't natural. The lives that we are leading are not natural compared to how our ancestors lived when they didn't have all of the technologies that we have.
And how about, so you write that we have the capacity to grow a rat pancreas in a mouse and a mouse pancreas in a rat. The Chinese recently grew kidneys inside of pigs whose cells were more than half human. So there's a prospect of us growing human
Oh yeah,
organs
it's already happening.
inside of
Yes,
pigs
it's
and
already
yeah.
happening. And so we definitely are already creating these chimeric animals that have human cells in them. And it's not Planet of the Apes, although maybe it could be at some point, but what it is possible to grow human organs. We have about 115,000 people in the United States alone on the organ transplant list. And so if we can grow human hearts, human kidneys, inside of pigs, and it looks very much like we'll be able to personalize that because pig heart is roughly a good size for us. But if you insert your own cells, so that it's your own heart cells growing inside of a pig with other genetic modifications, are creating a heart that can be your heart and is less likely to be rejected by your biological system, so that you don't have to spend your entire life on immunosuppressants. That seems like a pretty great thing. Again, I feel sorry for the pig, but it's like a sorry, not sorry, because I'm not a vegetarian. So is it better for a pig to give its life so that somebody's child can live another 70 years, or give its life for the BLT burger at McDonald's? I mean, we're already slaughtering all of these animals.
Yeah.
There's an argument to be made, don't do
Right.
it. But if we're doing it and we can
Yeah.
grow human organs or cure cancers, I say let's go for it.
And it does seem that, we've been reading about hearing about lab grown meat,
Yep.
what you call cultivated meat, for a long time. I'm curious to know whether this is truly becoming more feasible or just something people are talking about. Reading that the first lab grown burger costs $325,000 for that burger, but the price, you write, has now come down to about $10 for a cultivated meat burger. So is it your view that we're actually going to see a kind of an option of cultivated meat in our grocery stores in a decade or more?
So certainly we, like you and me, will see that option within a decade or even less. But the real question, or the more significant question, is whether cultivated meat or cell culture meat, whatever you want to call it, will reach a cost, scale, and quality level that it can take a big dent out of the animal products that we collectively consume. Because if it's just a niche product for a few of us to consume to feel like we're doing our part, that's certainly great. But what we need to say is, right now we have the 72, 73 billion land animals that we're killing per year. And most of them are chickens. But let's just say that we want to kill fewer animals. And within that, maybe more chickens and less cows, pigs, and sheep. How are we going to do that? And I think this is part of the answer. But it's not going to happen on its own. It's not just a bunch of people working in their garages. We're going to need pretty significant investments, including by governments, in the basic science and the whole infrastructures that surround creating a field. And that's what we've done with lots of other things. And whether it's the internet or other technologies, our government has invested hugely. And so I certainly think there's a lot more work to do.
And you describe a scenario where you go to the grocery store and they're cultivated meats, they're plant-based meats, they're original organic meats, which maybe is a fancy heirloom product.
Right.
But you also throw out a scenario where you write, I'm quoting you here, following the Tesla model, high prices for specialty foods like cultivated Wagyu beef, bluefin tuna, foie gras, lobster, and Sturgeon caviar could then subsidize the broader industry. So what we might see is like perfectly marbled, insanely delicious and healthy grass-fed steaks or beef or what have you, that's actually healthier, delicious, and no conscious animal has suffered.
Yep.
right? Because you're basically growing the animal tissue in the absence of a brain and a nervous system, right? So,
Yeah.
so you could make a case that it will be more ethical, more delicious, more healthy for our bodies.
Yeah, and say yes, absolutely. I mean, I have to agree with you because you're quoting me, but I think that it's a real vision. I mean, the Tesla model was create a premium, high cost, high quality product, and then use that to build a company and an industry, and then sell things cheaper. So it could well be that we start with premium products that are a little more expensive, and then we expand through that and create more sustainable companies over time.
The LinkedIn Podcast Network is sponsored by TIAA. In the last 100 years, we've seen financial markets swing, new currencies come and go, decades of savings lost in days, all showing that a retirement plan without a guarantee, quite simply, isn't enough. So more than a retirement plan, TIAA makes you a retirement promise. A promise of a guaranteed retirement paycheck for life. A promise that pays off. Learn more at TIAA.org/promisespayoff.
All right, let's talk about another area where biotech could be transformative. And this is one I did not see coming or hadn't read about at all, which is building materials. Apparently, we've developed a form of bacteria that can repair concrete.
Yeah.
Can you tell us about that?
People get that natural materials can grow very quickly. Like where do coral reefs come from? They just grow with this incredible speed. And so now there are people, as we just understand these living systems and are able to manipulate living systems. There's a company in Boulder, Colorado called Prometheus, which is pioneering efforts just to essentially create living cells that can form a gel that connects sand. And the U.S. Air Force, for example, is experimenting with these kinds of materials that you can just spray them on a desert and they can turn into a runway. And this points to this broader thing of just we have this model of industry that we cut down or dig up the raw materials that we need. But now there's a whole new model of growing, and every country, every major country in the world now has a bioeconomy strategy, which is saying, how can we grow the materials that we want differently? And whether it's building materials that are living until they're kind of set in place, or whether it's new kinds of fabrics like spider silk, or a whole range of different alternatives for plastics, oils, woods, really kind of anything and everything. And it's the same point as with the food. We're not going to not want the things that we want. So if we accept that we're all going to want to have high quality of life with nice houses and clothing and stuff and safety, how are we going to get it? And I think that's the question we need to be asking.
So you mentioned spider silk. This was another head spinner in your book. Spider silk turns out to be the strongest biological polymer on Earth.
Yep.
You write, it is by weight 3 times stronger than Kevlar. It can stretch up to 500% before breaking. And last year, Chinese scientists announced they had birthed the world's first silkworms, able to produce not silk, but spider silk. So what could we do with this? I mean, I guess...
Oh my God, you could do anything. I mean, so with this, we could build buildings. We can use it for electrical wiring. It's not rejected by our bodies. So it could be, there's a whole host of applications inside of humans, whether it's to close wounds. It's almost unlimited. It's this magical substance. We could make armor for our warriors. Really, it's stronger than Kevlar, pound for pound. So it's an unlimited list. And again, this is just one of those things where our natural systems have evolved over 4 billion years. And there's this word synthetic biology, which suggests that humans are creating biology from scratch. And that's not at all the case. What we're doing is tweaking evolved systems, natural systems, in order to meet our needs. That's what all of agriculture is. That's what all of healthcare is. And now we have this increasing capacity to do that exact thing. Some call it nature co-design, to develop new kinds of materials and processes to help construct the world around us.
You write, we shouldn't expect to see skyscrapers grown from the ground up entirely from living materials anytime soon. But we shouldn't reject the idea out of hand.
Yeah. No, I mean,
Right.
it's just imagine it. I mean, just how I talked about a coral reef or a tree or a forest,
Yeah.
how quickly those things grow. So there's no reason why we can't manage and manipulate living systems. Just imagine a big coral reef within a frame that maybe we set up and we have it grow. And then there's some kind of signaling where we just basically turn off the cellular growth or add some kind of material that just hardens the coral reef into something that's more familiar as a brick. And there are places around the world, India and elsewhere, where people are just using pieces of coral as bricks. So again, we have one model of interacting with the world around us, of cutting down and digging up. And now we're at the beginning of imagining and building a new model.
Yet another kind of fascinating area where we could see some interesting use of natural systems is what you call DNA data storage. It turns out DNA is 1 million times denser than silicon, and it can remain readable for up to 2 million years, right?
Yeah.
So it sounds like there's some hurdles here, but this could be a revolutionary way
Yeah.
to store
Yeah.
information.
Nature has solved the problem over 4 billion years of data storage. I mean, that's what we are. Every one of our cells, or almost every one of our cells that has a nucleus, has a genome. And that genome is the record of all of life over the past 3.8 billion years. So it's an incredible living data storage mechanism that is still working and is still working incredibly well. Silicon is also a great mechanism for storing data. It lasts under the right conditions, maybe 30 to 50 years, which is why we need to be constantly, essentially recopying all of our data. And every 2 years, we're creating more data than all of human history up to that point. We're doing it over and over and over, which is why we need to get these bigger and bigger data centers. So we're going to have to think about how we make computing and data storage more efficient. And DNA is the world's, as I said, the world's greatest storage mechanism. Right now, it's much more expensive. It's harder to store information in DNA, at least for us to do it, than in silicon. But again, all of these areas we need to be investing. We need to be exploring. And the good news for us is that these natural systems already exist. I talk about in the book, Carl Benz in Germany in the 1880s, inventing the car. But imagine if he had had a Porsche parked in his workshop, and every time he was thinking, he could say, hey, how does this Porsche work? And go look in the Porsche and then say, oh yeah. So we have that. We have 4 billion years of evolution, and we can look at, say, how has evolution essentially solved this problem? And then what can we learn about that in trying to solve an analogous problem? And that's why these capabilities, we're getting the ability to interrogate natural systems in ways that are historically unprecedented. And with that comes an increasing power to manipulate those systems.
We've talked about massaging biological systems to improve food production, building materials, computing. How about improving ourselves? How do you think about the path for human augmentation?
So my last book, Hacking Darwin, was about the future of human genetic engineering. And so I certainly believe that we will continue to augment ourselves. We need to recognize that we are already augmented humans, certainly in the living systems that are around us. But any of us who are vaccinated or who have pacemakers or cochlear implants or all sorts of things, we are already superhumans. But now we have the ability to begin the process of manipulating humans on a deeper and more fundamental level. I was a member of the World Health Organization Expert Advisory Committee on Human Genome Editing. And our group was created by Dr. Tedros, the WHO Director General, after the announcement of the world's first CRISPR babies. The first CRISPR babies were born in China. So we already have genetically modified humans whose pre-implanted embryos have been modified using CRISPR-Cas9 genome editing. So that cat is already out of the bag. And the question is, where will that and other manipulations go from here? And in my mind, there's absolutely no question that that is the future of our species. And there's absolutely no question that there's a danger of highly unethical work being done now, like He Jiankui, that Chinese scientist, did in 2018 and 2019, and is frankly threatening to do again, at least if you trust what he's saying on Twitter. So that is the future of our species. We're going to want it, because how could you tell somebody who's about to have a child and the child's going to have a deadly genetic disorder that we could have totally prevented that genetic disorder and changed a life of a 2-year life of a child who died in terrible agony to a 100-year life of that same child who lived a long and fulfilling and contributing life. And we'll say, oh, we didn't do it because there was a taboo about this one specific form of manipulation. We're not going to do it, and it wouldn't make sense for us to do that. But that doesn't mean the fact that we can imagine scenarios when it would be, in my view, fully justified, doesn't mean that every kind of cockamamie intervention that somebody can think up would be justified.
It's easy to imagine these relatively uncontroversial cases where there's a family that's suffering from a really challenging genetic health problem that can be cured. But as you write, it is becoming increasingly easy to select from among many, many different possible versions of the children that you choose to have. And it's hard for me to imagine a scenario where there isn't a slippery slope towards people choosing to have much smarter children, and that becoming a kind of arms race of sorts, right? That if my children are growing up in a world where everybody's enhanced, we better do the same, honey.
I
mean, does that?
Yeah, and I wrote about that at some length in my last book, but there's no doubt that we will see that kind of arms race competition. And that's why, with all of this, what we're talking about is the manipulation of life and of living systems. And this is really serious business. And that's why it must be regulated. It must be governed. Yeah. This isn't a case where people can imagine positive scenarios or even desirable scenarios. And then the answer is, oh yeah, let government out of the way and people can experiment on their own kids, on other people's kids as much as they want. That affirmatively should not be the case.
But how exactly should we govern gene editing and AI and all the other biotechnologies Jamie's been describing? The answer, right after the break.
From the minds of visionaries to the desks of disruptors, I'm Lars Schmidt, host of the Redefining Work podcast. Join me each week as we explore the new world of work through the lens of those shaping it. CEOs, HR leaders, investors, and more. Be a part of the conversation that changes everything. Subscribe to Redefining Work today.
So world governance of our acceleration of technologies does seem to be pretty critical. We had a conversation with Bill Gates a few weeks ago in which he said about AI, if it were possible to slow down the pace of AI acceleration, a lot of people would want to do that, right? The implication being it's not possible. You've spent a lot of time focused on global governance, collaboration between countries. Do you see a pathway for a kind of better global governance of all these converging, accelerating technologies?
So for sure, the pressure of this moment is so great that we're all in this competitive rat race, and we're in it individually. You see it with companies like OpenAI, which was created as a not-for-profit to prevent the kind of arms race that they themselves sparked once they became a for-profit company. And you see it certainly with the United States and China and others, where we are racing for these different supremacies. And whether it's with AI or quantum or all these other supremacies that everybody wants, because they recognize that these are going to be the most powerful technologies of now and certainly in the future. So if we don't change anything, we do not have the mechanisms in place to address any of these global challenges, and whether it's technology governance, climate change, nuclear proliferation, pandemics. You could just go through one at a time, and you would see that in every one of them, we're not solving the problem. And we're not solving the problem because we live in a world of zero-sum competition. If Eleanor Roosevelt had a time machine and traveled from the 1940s to today and said, well, did the United Nations project that she and Ralph Bunche and others had envisioned, did it succeed? All of those people would be heartbroken. They would recognize that the UN is doing something, but we certainly do not live in a world where the United Nations plays any kind of meaningful role in solving our big problems. And so one of the reasons why I and others founded the organization One Shared World in the early days of the pandemic was this recognition that our world needs an upgrade to our global operating system. And that sounds crazy and ambitious, and it is, but we've had it in the past. After the 30 Years' War in the first half of the 17th century, the treaties of Westphalia established the concept of the modern nation state, which was new. Now we're at another one of those mismatch moments where we don't have the organization to address any of the big challenges we face. And so we will address this. There's two ways. One, most likely, is we're not going to do enough, and then there'll be a synthetic biology pandemic killing billions of people. There'll be an ocean ecosystem collapse because of all of the overfishing or global warming. There'll be a nuclear war or something else. And those of us who survive will climb out of our holes like we did in 1945 and 1648 and say, hey, we need a new model to have a safe future. And then in that model, we'll build a future recognizing that the principle of the mutual responsibilities of our complex global interdependence must be respected. Or less likely, but more desirable, before that happens, we can come together with a spirit of love and openness and say, hey, if we have a synbio pandemic or a nuclear war, an ecosystem collapse or whatever, we're all going to be screwed because we're all in the same boat in our interdependent world. What are the things that we can do now? And so that's certainly my view, is that we need to address these problems one at a time. We need to expand the capacity of organizations like the United Nations to address global problems. And we need to begin conceptualizing what an upgraded system would look like and how it would function. That seems crazy, but in 1795, Immanuel Kant, he imagined a League of Peace to address the problem of these competing nation states. It took 150 years and 2 world wars and the failure of the League of Nations to get to the Treaty of San Francisco in 1945. We don't have that time. And so while I'm really excited about the technology advancement, and I listened just today, actually, I was listening on my morning run to a podcast with Demis Hassabis, who you mentioned. Demis is such a brilliant person. And of all the people in the world, he's one of the people who I respect the most. But at the end of every one of these interviews with every one of these tech people, it gets to this question.
Yeah.
And then it's like, wow, the technology is so powerful. What do we do? And then they say, oh, we need a system. But nobody is investing any time in building that system. So all the money, all the energy, all of the excitement is in advancing the technology. And if we don't put a lot of energy and effort into governance, and by governance, I don't just mean government regulation, I mean what everybody does at every level, we're really going to be in big trouble.
Yeah. Well, I like the optimistic note that we have come together in the past. And when I'm thinking optimistically, I think of Robert Wright's wonderful book, Non-Zero, came out about 20 years ago, in which he makes the case that more collaborative humans have outcompeted less collaborative humans for all of human history. And we're moving towards world governance, maybe sometimes 2 steps forward, 1 step backwards. But so that is the hope. On the other hand, you have Nick Bostrom's vulnerable world hypothesis, which basically says the more powerful our technologies become, the more likely it is that we develop something that exterminates the species, which in your 2 scenarios, one is that we almost exterminate the species and then we pull it together. The other is that we get ahead of that now and figure it out. Right. Of course, the third scenario, which, Sam McCaskill, who we had on Will McCaskill, who we had on the show, among the effective altruists are, have described us as in the drunk driving adolescence of our species. Yeah. And the question is, will we drive into a lamppost?
Yeah. And the thing is, we'll certainly drive into many lampposts. And I feel very badly for these whatever what are they called? The altruists?
Effective altruists. Yeah,
talk about somebody ruining your brand in one fell swoop. So their brand is ruined. But I certainly do believe that we owe something to future generations. I certainly think that we need to prioritize how we allocate our energy. And I write about in the book about how I just feel like putting all the energy into eliminating plastic straws was kind of a waste of time because that wasn't the highest priority. So we need to prioritize. It's going to be hard to wipe out all of humans. I mean, we just kind of keep going. But certainly the Neanderthals were wiped out. Others, many millions, billions, perhaps, of species have been wiped out. And I believe that we have these 2 futures ahead of us. Is there a possibility we'll wipe ourselves out? Yes. Is there a possibility we'll harm a whole lot of us? Yes, even more than wiping ourselves out. And is there a possibility that we can come together recognizing that we have this great set of opportunities, recognizing that we have the potential to build a world that really works better for everyone? And I think that we can get there. But it's going to take a lot of participation and it's going to take a lot of leadership at every level. And certainly for me, with writing this book, with the work of One Shared World and the other things I'm trying to do in my life, I just want to feel like I'm at least doing my best to contribute in some little way. And when I talk about the book, I always say this book, it's think of it like a baton. You hand it to the next person. And then they have to take this baton and they run and they hand it to the next person. And that's the history of our species. And it's just, we're running faster. And so we really need to be thoughtful and mindful about the best ways forward.
Well, we hope that you're going to continue to run with your baton, because I think One Shared World and all the other work you're doing is fantastic and certainly part of the solution. I love your observation, Jamie, that which you make throughout the book, that even though we're transforming our world, we are of this world. We are part of nature, and that which we create is also an expression of nature in the sense, right? So even this otherworldly AI that we're building, when you think about it from the perspective of an alien looking at our planet, it is every bit as natural as the coral and the trees growing. Let's hope we can all grow in the right direction. Thank you so much, Jamie, for your time today. Such an interesting conversation.
Really, my great pleasure.
Jamie Metzl's new book is called Superconvergence: How the Genetics, Biotech, and AI Revolutions Will Transform Our Lives, Work, and World. Pick up a copy wherever books are sold. If you enjoyed this episode, there are 2 from our archives that I'd recommend. The first is a conversation I had with Azim Azar about his book, The Exponential Age. I love this one. And the second is my interview with my sister, Amanda Little, about what we'll eat in a bigger, hotter, smarter world. You can find links to those shows in the episode notes. And sis, I loved your episode too. Also in the episode notes, a link to buy a ticket to our September 11th event with Yuval Noah Harari. Really looking forward to this one. Hope to see you there. Today's show was produced by Caleb Bissinger. Sound design by Mike Toda. No matter how different the world is in 20 years, we hope we'll still be working with the great team at the LinkedIn Podcast Network. Next week, we've got a real treat for you.
I do think of myself as finding a kind of pleasure in the world around me before I describe that world. I have to be excited about the material, and one way I can sort of sense the excitement is if I'm laughing.
Recognize that voice? It's the one and only Michael Lewis. He'll be on the show to talk about his latest book, Going Infinite, as well as the art of storytelling. You won't want to miss it. I'm Rufus Griscom. More to come.